Thank you very much, Chairman. Before I start, I'd like to share how excited I am to be a ranking member on the Subcommittee on Space and Aeronautics. I'm pleased to be working with Chairman Babin, the full committee Chairman Lucas, and Ranking Member Lofgren. I'm proud to be the son of an aerospace engineer who worked in aviation and the Space Shuttle program. So this is in my blood. I grew up in Rockford, Illinois, and took my dream job as a meteorologist. And of course, we all know that weather impacts everything. It's an understatement to say that I am absolutely excited to be here. I want to welcome our new and returning Democratic members of the subcommittee. I look forward to working with everyone and our majority colleagues on what promises to be a busy and important year for space and aeronautics policy. Returning to our meeting, thank you to Chairman Babin for holding today's hearing to examine the FAA's research and development programs. I want to welcome our distinguished panel of witnesses here today, so thank you all for being here. As members of Congress who commute back and forth between our districts in Washington, D.C., often weekly, we depend on the safety and the reliability of our nation's air transportation systems. So thanks to the thousands of men and women at the FAA and its industry partners, the United States has maintained a strong safety record in commercial air travel across many decades and generations. FAA's research and development activities are essential to ensuring our safety. Fire safety, aircraft de-icing, flight traffic management, and airport pavement. I mean, these are just a couple of the examples of research that continues to drive safety at the forefront, and it means that our U.S. commercial aviation industry is successful. It's important to recognize, however, that the COVID-19 pandemic had devastating impacts on commercial air travel and our supply chain. While recovery is still underway, the number of world total passengers in 2022 was still down by 29% as compared to 2019 before the pandemic, according to the International Civil Aviation Organization. Today's hearing provides an opportunity to explore how research and development can help build resiliency into our national air transportation system. Commercial aviation is on the cusp of transformational changes to bringing with it the potential for economic growth, jobs, innovation, and environmental stability. Fully benefiting from these opportunities and ensuring the United States leadership will continue and will require managing significant changes to the already complex National Airspace System, the NAS. Emerging technology like drones will be joining the skies along with piloted commercial passenger airplanes, and we need to make sure that safety matches the technological innovations. In addition, the demand for lighter, quieter, more fuel-efficient and climate-friendly aircraft are leading to new aviation technologies, including biofuels and electrification. So I have confidence that the FAA, the United States aviation industry, and the nation's universities can successfully work together to navigate all of the changes. And if we give them the appropriate policy direction and resources, we can do it. That's why today's hearing is so important. The subcommittee will prepare R&D title for this year's FAA reauthorization, and our discussion this morning will inform that work. To that end, I look forward to hearing from our witnesses to the following questions. Is FAA's R&D effectively addressing the challenges of integrating new and evolving technologies and systems into the NAS? To what extent is FAA's R&D advancing U.S. leadership in sustainable aviation, reducing our environmental impacts, and meeting the Biden administration's target goals for achieving net zero emissions by 2050? Do the FAA and the industry partners have the workforce that's needed to meet the challenges? How can we build resiliency into our commercial air transportation system to mitigate the effects of unplanned stresses on the system? And so I do again want to thank our witnesses today for being with us. I look forward to your testimony. Thank you, Mr. Chairman. I yield back the balance of my time. I'll begin with you, Mr. Cunningham. In your prepared testimony notes that other countries are investing heavily in aeronautics R&D and at levels that that may surpass those of the United States. How concerned are you about the level of the United States investment to advance aviation technologies and innovation? And I think the follow-up would be, what would be your top priorities for increasing the investments in these R&D programs, and why?
Okay, thank you for the question. You're absolutely right. If you look at Europe, for example, their investment into R&D is a little over an order of magnitude higher than what we have in the United States. Now, that can benefit companies in the United States, but oftentimes that's going to ultimately have a long-term benefit for Europe because they're the ones investing the money. When I look at what we can do with that, it's the technology itself around especially areas including sustainability and safety. But Dr. Hansman brought up an excellent point, which is the technology itself is very much the step in the right direction, but how we certify that technology and how we safely put it into practice is going to be key. So take, for example, hybrid electric propulsion. We've got a great amount of investment going into that, both from our own company as far as the government as well, but we don't yet know how to certify a hybrid electric propulsion system on an aircraft. That's going to be equally important as the technology itself to actually facilitate getting that out there, even into areas like general aviation, which we think is going to be one of the early adopters of technology like that to help sustainability.
As we all know, weather is one of the most dynamic factors that affects flight schedule. From small-scale thunderstorm complexes to, for instance, the big Arctic blast that nearly halted air travel before Christmas. Weather is a stress point that can lead to real economic and human impacts. In the near future, FAA is likely to be managing new types of systems in the airspace. Dr. Hansman, it's not just manned aircraft that are stressed. To what extent do new systems such as drones respond to weather differently than commercial aircraft, and how important is it that the FAA and drone operators understand how those operations respond to different parts of weather?
Sorry. So the small UAS and particularly small UAVs are subject to different types because they're small. Turbulence will impact them differently. Most UAS can't operate in icing conditions. If they ice up, they have problems, et cetera. For small UAS, it's not such a problem because if the airplane goes down, it's bad as long as it doesn't hit a person. It's going to be a real challenge as we move to more automated system. So ultimately, there are people who are proposing to fly large UAS autonomously and whatever. It's tricky for some of these systems to be able to know, for example, whether to go around or through a thunderstorm. Today, that's done as a subjective analysis by the pilot. So, again, how do you decide that an autonomous system is good enough to know whether to go through a thunderstorm, around it, or over it? The other thing I would say on the weather side is that we are in a much more connected world. So on the cockpit today, I have much more information than I had years ago. It used to be you would play 20 questions with the air traffic controller to try to figure out whether the thunderstorm was bad or not. Now you're getting data from many sources. So I do think we're in an area of an improvement there.
How is, and forgive me for going into meteorology more as the meteorologist, but how is the FAA doing the research such that as the innovation of UAS continues, we're able to meet the demands?
Yeah, so there's a couple parts to this. First off, that the FAA is involved in distributing the information and setting up requirements. Much of the research associated with the meteorology is done by the National Weather Service, National Center for Atmospheric Research, et cetera. So there's efforts such as weather in the cockpit, efforts to try to figure out how to present the information to the crews better, et cetera. There's another thing, which is the airplanes themselves become probes in the system. So they're microsensors that propagate through the system. So how do you integrate that? One of the things in the plans that we've been trying to do is system-wide information management, figuring out how to send information to everybody. We haven't been as effective as we had, and the NOTAM is sort of an example of this, in part because if you make the system connected, you introduce new vulnerabilities. So now you're more subject to a cyber attack because someone can get into that. So this is the challenge of this incredibly complicated and safe system, trying to figure out what's okay to turn on to get the advantages that you'd like to get.
Thank you very much, Mr. Chairman. I yield back.